Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. We have already gone through the general aspect of entrepreneurship. Last week, we looked into entrepreneurial context and goal context, and we look into several aspects of social entrepreneurship. At the same time, we look at entrepreneurship in small businesses. At the same time, we also look into the global innovation index. Right. So you probably have already gone through the slides and look into the video that I have shared last week with regards to the topic. So for today, we are going to move into another aspect of our course, which is called the route to commercialization. This is where you bring ideas to market, right? Later on in our course, you are going to do your own small assignment to come up with an idea and to grow the idea to have a commercialization plan, right? So for today, I'm going to share with you some of my very own experience of bringing the products from idea to market, meaning that the ideation, the coming from research, going through the process of development, and then going into the phase of commercialization and as well as business. Okay, so I will share with you in terms of there are currently four products that I have managed to bring from conceptualization to product design, prototype, and then test in the real market before we bring it to business and real business. So the first one is called My OBE. This is coming from my own collaboration with a few other colleagues from the Faculty of Engineering, University Putra Malaysia. So we come up with a system called My OBE. My means Malaysia, Malaysia outcome-based education system that were used in order for us to manage the educational aspect at the Faculty of Engineering. So way back in year 2005, 2006, where Malaysia during that time would like to go into what we call it as the Washington Accord. Washington Accord is an agreement between institution in members country that sign the Washington Accord under the International Engineering Alliance. It is called Washington Accord because the document being signed in Washington, that nothing to do with other things. It's just called a Washington Accord because it is being signed in Washington in earlier, I think in late 90s. But in 2005, Malaysia has decided to embark into the journey where we would like to have our engineering program that were offered in Malaysia to be also accepted internationally. Okay, so this is to allow the what we call it as the engineers mobility, meaning that engineers from Malaysia, graduated from Malaysia, they can work in other Washington Accord countries. And currently in year 2024, we have already the Washington Accord members country has already reached nearly 30 countries all over the world. I think the numbers is around 28, and we have provision members and so on. You can get more information about the Washington Accord countries or under the International Engineering Alliance. So with regards to our offer, with regards to our product that I personally involved, the My OBE, basically to cater the system of outcome-based education. Because before 2005, all of our education system the way we teach our program, our courses, it is quite traditional, meaning that when lecturer comes into the class, they will just tell the student, okay, we are going to discuss or we are going to teach certain topics, and start throwing information, explaining things and so on, without any planning in terms of how to know whether the student attain certain attributes. Okay, through the requirements of the International Engineering Alliance. So we in Malaysia, the Board of Engineers Malaysia have already set certain outcomes. We have 12 program outcomes or program attributes, student attributes that need to be achieved by all students going through engineering program in Malaysia. Okay, so when we first started to implement outcome-based education, we find out that there are so many papers, so many procedures, so many documents need to be filled in order for us to track the student attainment, right? From all of the courses offered. So we want to ensure that the students attain certain outcomes. So this is just a snapshot of the system. Okay, we hire a programmer, two programmers actually, and we come up with the system that enable us, the administrators and the lecturers, to monitor the attainment or the cycle of the outcome-based education. For example, like when we need to set what are the program outcomes. For example, for our program, the Master of Engineering, Innovation and Engineering Design, we have 6 program outcomes. So those program outcomes being crafted or being designed in such way that is the promise. That is the promise. At the end of the program, the student would be able to attain certain program outcomes. And then come into the teaching and assessment plan, where lecturers being assigned certain courses, they also being assigned certain program outcome. I have already explained to those who attended our lecture in week 1 that through this particular course, we have 3 program outcomes that we need to address. So at the same time, we in the system also, we look into the assessment plan, whether there are examinations, what type of level of difficulties, what type of taxonomy going to be tested, whether there are courseworks involved, and then we also provide course assessment. We want to ensure whether all of the course assessment being achieved. And then finally, program evaluation where we check whether how students perform, not just in examination, but at the same time in their outcome attainment, whether the students attain the outcome or not. And then we can then the following semester we do harmonization, and we intercept or we act upon it, whether there are improvement need to be made. So basically, this is like an ISO system, quality management system, where we have plan, we do, we check, as well as we act, the PDCA. So this is basically a summary of a product that I and my team come out and let us look into the commercialization time. What it is that I'm very sorry, the slide is quite crowded. We try to remove few things, but I think I will try to use this slide to explain to you how it started and until we come to today's timeline. So as I earlier mentioned to you, we started the implementation of outcome-based in the year 24, 25, and we started to organize workshops for lecturers, right, to really understand how is it being implemented. And we found out that there are issues. There are issues because there are issues in terms of, as we go along, as we implement more courses in terms of outcome-based education delivery, we've realized that we we need a system to monitor and to cater the needs of the implementation. And then that's where we crafted the program design and implementation, and then we come up with an automation system. So I call it as a research stage in terms of from idea going into solution, identify problems, and then going into the solution. We come up with a solution that we use ourselves. We use an automation system during those days, the early year 2008. And then we managed to seek seed funding from the Ministry of Higher Education to provide us with some allocation to further develop the system that we have already initiated. Okay, that's where once we got the seed money, we come up with the MyOBE prototype. All right, and from there we also started to patent file. We file for patent the flow chart of the process of outcome-based education in Malaysia. So we are the first to file patent it, and we also file a copyright in terms of the programming of the system. And Alhamdulillah, in year 9 or 10, we managed to obtain Australian patent. Of course, we file patent for Malaysia, we file patent for US, for Japan, for other countries, but somehow Australian patent being granted quite fast during those days. At the same time, during the development stages from 2009 until 2011, right, we gone through some competition, innovation competition internally at UPM, internationally at what we call it as the Malaysia Technology Expo in 2011. We also go for Percipta 2011, and we managed to somehow attracted our first client. This is a Unicel, University Selangor. So they are also obliged to run outcome-based education because they are running engineering program over there. So they attracted to our software, the MyOBE. This is where we piloted the program in Unicel. Of course, when we say piloted, they also pay us. This is where we started to gain revenue through University Putra Malaysia. And that's where we go into the next phase of innovation, which is we call the commercialization, from research to development and then go into the commercialization, right? So from there, we started to promote our product to other institutions such as Polytechnic, University Technology, MARA. We have also UPNM, University Pertahanan Nasional Malaysia, as well as a university in, this is a what? King, is it Nizwa University or King Saud University? So in Saudi Arabia, okay, as well as University Nizwa in Oman. I do not have their logo. That's where we started to sell the software as well as the training side of it. Of course, when you buy software, we need to also train the people, train the user, train the lecturers in the respective universities under UPM Holdings, that they managed to help us to do commercialization. And at the same time, we found out that we are very busy. As a lecturer, we cannot be a full-time people to do the marketing, to do the software installation, to train people. We then managed to get a seed funding, another seed funding from UPM to create a spin-off company called MIQ EduSys. Basically, this is a Malaysia quality education system, right? So Malaysia Innovation Quality Education System, MIG EduSys, a company, it is a spin-off company. We got a seed money from UPM to hire our programmer. Our programmer become the first CEO of the company, and we then license the, we means UPM, University Putra Malaysia, license the technology, because we already obtained a patent over there and a copyright. We license it to the company to do the business. So at the same time, we 2016 we got the Japan patent granted, and year 2018 we got the Malaysia patent granted. So you can see that when you apply for patent, it is not immediate. Australia patent took 1 year. Japan patent took how many years there? Nearly 5 years. Malaysia patent 7 years to be granted, right? So this is the journey. Of course, another one, this is GMI, German Malaysia Institute, also bought our product using cloud system. So, and the company now already evolved into another, it's already being bought over. So it's already graduated from the spin-off company from UPM. So you can see that from the idea muted in year 24 until I think 2014, it took nearly 10 years for the idea that we have already come out to be realized into the market. All right, this is just one snapshot of one example. Let me go through another example on my very own as well. So it is a medical device, going from engineering education, going into a medical device called vacuum blood container. I believe maybe not all of you, maybe some of you had an experience to get blood tested, blood testing in hospital or in clinics, where the doctors or the health workers will withdraw your blood using syringe, and then they will put your blood into a tube, something like that. Okay, so that is what we call a blood container. So what we have here, it is an innovative idea, innovative design, where the current design of a blood container, right, it is quite similar. They have a cap, they have the what we call it as the rubber enclosure, and then the tube itself, right? So the way it works, basically, the traditional way it works, basically, the manufacturer need to punch through the rubber enclosure to withdraw all the air from the tube. Okay, so that basically, even though the rubber itself is self-healing, right, it can close it gaps, the gap that created by the syringe, but during the process there are leakage, meaning that the blood container cannot withstand a longer time, right, because of the creation of the hole by the penetration of the needle to withdraw the blood, to withdraw the air from the tube during manufacturing process. So we come up with a solution where we do not have to penetrate or creating holes on the rubber enclosure, where we design a what we call as a groove or a passage for the air to be extracted from the tube without penetrating. Basically, during the vacuuming process, right? So we put the cap half closed to allow the air being extracted from the tube before the cap being closed fully, right? All of this being done in a vacuum chamber. We design a vacuum chamber. We put the tubes inside the vacuum chamber, and then we extract all the air from the vacuum chamber before we press the cap as well as the rubber enclosure to close the gap. All right. So Of course, I have another story there. This is the timeline. Just to highlight to you that the idea of the vacuum tube and the people who get involved in the vacuum tube development are students coming from this program, innovation and engineering program. So I group a handful of students, I think about 5 of them, and to help to develop the process, to do the design the tube, design the vacuum chamber, design the manufacturing process, and until it is completed. So it is started in year 2006 with our first student under innovation and engineering design. Currently, Mr. Nazim, our first student, already a lecturer in UTEM Melaka, right? And then followed by a couple of students from UNIMAP. I think 3 of them already got their PhD, right? From about product design. Okay, so the idea started in year 2006, 2008, and we come up with a product design. We have a laboratory prototype and proof of concept. Okay, with regards to the product. Okay, product itself. And for your information, in Malaysia during those days, there aren't any company, local manufacturer, right, producing the vacuum blood container, right? So that's forces the Ministry of Health to import, and they have to import all the vacuum blood container overseas, from BD, from I think there are other, I can't remember the name of the company. So you can Google it. So basically, it is a nation needs. It's not just about trying to penetrate the market, but basically we want to fill the gap, right? By having our very own locally produced blood container, because it is what we call it as, you cannot reuse a blood container. Once you use it, you have to dispose it carefully. Okay, so we also go into, once the research stage is completed, we then move into the development stage where we start to file patent our product. Okay, again, why Australia, why US, why other country? Because we want to export the product later on. Okay, so that's why where we want to protect the ideas, and we come up with the engineering prototype. Actually, during this stage, we are already working with the local manufacturer, a company called Celiatech Industry. They are known in the medical devices, so we engage with them. They do plastic injection molding, so we work the engineering prototype closely together with them, right? And as you can see that from year 2010 until year 2016, it is quite a lengthy process of development, because we need to go through the medical certification. We have to go through all sort of medical audits. We need to do clinical trials. All of it being done during this stage together with our partner from Celiatech Industry, right? In 2015, we managed to get the patent granted, okay, for the vacuum blood container. And of course, early 2016, the university decided that since we have the patent, we have the technology, then we decided to approach Celetech Industry, so now known as Celetech Holdings, to sell the technology to them, instead of we ourselves at UPM to do all the commercialization. They actually agreed to buy the technology. They bought the patent, basically the patent owned by UPM. Then UPM sell the patent to patent rights to Celetech Industry. And I personally managed to help Celetech Industry to secure commercialization grant from the Ministry of Science and Technology under MITE, Malaysia Industry Government for High Technology, a funding of 5 million Malaysia ringgit to mass produce the product product at their factory in Subang. Now they are situated in Kota Damansara. And for your information, once Sediatech bought the patent from UPM, they are fully responsible to, because they have already paid from the 5 million ringgit that they managed to secure from Ministry of Science. Then they pay UPM on the royalty, paid UPM on the IP that they bought, and UPM pay the inventors. Okay, that's how it relates. And there's no royalty over there, because we UPM sell the product directly to them. Okay. And from there, the product, Alhamdulillah, in 2018, after going through 2 years of further clinical trial and audit by Pharma Niaga, as well as Ministry of Health, the product managed to penetrate the hospitals. Now, if you go to government hospital, especially, they are already using product called VacTube. Okay, VacTube from Celia. Right? If you happen to go to the hospital to take blood, maybe you want to ask what are the brand of the vacuum blood container. If you found it is VacTube, so you remember, oh, this is Professor Rahim product from UPM. Okay, another product, another collaboration with Celiatech is basically called Safety Syringe, right? Of course, since we have a good track record working with Celiatech, they are the only, there are in Malaysia, there are two manufacturers of the needle, and needle for the syringes. Okay, so one company is their competitor. Basically, it is a the partner of Celiatech. He formed another company, and they also becoming a competitor, a healthy competitor for in the market. So Celiatech also produces these syringes. Okay, it is called SJ syringes. So, but they do not have safety syringe. What we they when they approach us at UPM, they approach me. I find out that this is a very innovative idea, where we need to come up with a product that allows the syringe to be fully disabled. Once they use, they cannot be reused, because it is you have human contact, you have blood, you have all sort of chemicals coming out from human, so you have to dispose it carefully, right? So this is a potential product, and we managed to also patent it. Let us look into the development, the commercialization timeline. It is actually overlapping with the earlier product that I have already explained, the VacTube. Okay, so ideation started in 2008, and product design, laboratory, proof of concept. Again, the product itself involve three students from our program, a Master of Innovation. If you are taking a subject with Dr. Adi Azrif, a lecturer at our Department of Aerospace. He also a product of this project. We also have a guy from the industry, Major Saleh Yaya. We also have another student from UNIMAP. Okay, and this K. Mat Isa is Mr. Khairi Mat Isa, the general manager for Celiatech. And we file so many countries in the intention to penetrate the market in Africa. This is South Africa. The market in UAE, Indonesia, India, again the normal Japan, US, and Australia. Okay, and we then managed to get a funding from Ministry of Higher Education on the prototype research grant scheme. And through the funding, we come up with the prototype. We do injection molding, plastic injection molding. We come up with the prototype. We managed to get US patent granted and Malaysia patent granted in 2019. Okay, similar to the vacuum tube, the product also being the IP being sold by UPM to Celatec as a technology transfer. Okay, so as you can see there, there is mode of commercialization from a spin-off company, technology transfer. There's another aspect, the royalty, licensing, okay, that are available for to go through the commercialization aspect. Before we end our session, I have another product that is still ongoing, okay. It is called thermal insulation paint, and I'm going to file a patent for this. It is in the process to file a patent, and this at the same time we are also filing a trademark for the name of the paint. We call it as a Putra thermal paint. So basically, what is actually here is that we come up with an innovative idea where the current situation of warm climate, our climate is getting warmer, and we need to cool down our room temperature. So that's where our solution comes in, where our collaboration with Spanish company called ICA, as well as a Malaysian company, Maju Scientific and UPM, we come up with a solution that be able to block heat or cold, and both sides, whether you want to block heat from coming into the house or block heat from going outside the house. And it is also anti-mold, anti-fungal. It can block moisture, dampen sound. It is a nature friendly. Why is it nature friendly? Because we use aerogel powder derived from rice husk. Because rice husk is abundant in Malaysia. We produce rice, but the rice husk we normally burn it, okay, and then dispose it. But we take the initiative to process the rice husk to become aerogel powder. We call it as an aerowder. Okay, that's why we call it as nature friendly. It also has the ability to retard fire. Okay, our product already being tested at high temperature, 1100 degrees Celsius, and it can be withstand the fire. And of course, by reducing the temperature of the house, we can save energy consumption. Okay, so the project itself being funded from Ministry of Science, Technology and Innovation. We have the agency here, Malaysia Industry Government for High Technology. We have the Ministry of Higher Education, as well as CDTI, Spanish company, Spanish agency, similar to mine in Malaysia, that provide funding and industry development. So we have the project consortium there. We have collaborators. This is an Aerogel Plus, a company founded by my ex-PhD student, Dr. Nadir, from Mauritius. Okay, so now he's in Mauritius, having this Aerogel Plus company that supply the technology to us, as well as a local pin manufacturer, Bina Pin. Bina Pin is a local pin manufacturer. For your information, this company, Bina Pin, is the only pin company that has halal certificate. Halal certificate means they are Sharia compliant. The paint can be used to paint mosques, as well as other religious buildings. Okay, let us look at the commercialization timeline. It is still quite early, even though the idea of having this aerogel powder has started way back in 2013, when my PhD student, Dr. Nadir, did his PhD under my supervision, and we tested the aerogel powder on various surfaces and being used for aerospace application, for aero engine application, and then it is being further developed together with my Nigerian PhD student, Dr. Ibrahim, now already back in Air Force in Nigeria. So we further develop the insulation panel before we go into seriously into the application of other aspect. So once we managed to secure the funding from the funders, we quickly go for laboratory and prototype testing, a proof of concept, and we did a low temperature test and fire test at our lab before we engage with the real environment testing. This is two houses. We managed to get in touch with the Suruhanjaya Perumahan Nasional Berhad, as well as the Kelantan Utilities Mubarakan Sdn Berhad in Kelantan. So to provide us with a real house, the two small bungalows in Pasir Mas, Kelantan, that were painted. One is painted using aerogel paint, the other one using a normal paint. And we did our thermography survey using infrared camera, and we also use thermocouples installed on sides of the building, and we monitor the house for nearly 2 months. We get continuous data using LoRa technology. Is a wireless internet protocol technology. So because the house is in Kelantan, it's around 13 hours driving, but we get the data through our server, because it is sending live data every minutes. They're sending data to us in UPM. So alhamdulillah, we managed to prove concept at lab as well as the real environment. And now I think 2 weeks ago, Suruhanjaya Perumahan Nasional Berhad, the agency that responsible for the housing for the people, they have announced that they are going to adopt our paint, aerogel paint, or what we call it as the Putra thermal paint, in 3,500 houses in Kelantan. They started in Kelantan because they are very happy that the house itself are colder, around 5 to 7 degrees Celsius compared to the other houses that are not painted using aerogel powder. So the journey is still ongoing. Okay, so we are most likely we are going to instead we are not going for license, we are not going for technology transfer, we are not going to go for spin-off company, we are going to go for the licensing, because it's much more lucrative, and UPM can get royalties for every liter of paint that being used by the agency for the people. So we can still get some royalties from there. So as you can see here, right, what you have already seen is a real life experience, my very own experience of bringing idea to market through various commercialization pathways. So later in our next lecture, we are going to look into the aspect of what are the commercialization pathway in terms of the definitions, in terms of the further explanation. But for today, my intention is just to share with you the idea about how to bring idea into market. So I would like to stop there for a while, so that we can allow question and answers. Maybe if you have any question, you may want to ask now.